Okay, so in the last hour we talked about these angles and stuff like that. We did some examples. Time for you to try some. So here, find out what each of those angles, figure out what each of those angles has to be. Okay, so how do we, you guys need a few more minutes? Okay, so the first thing we have to figure out, what type of relationship this is. Do these equal each other? No, they don't equal each other.
Oh, no.
Do these add up to a certain thing? Yeah, they do. Since they combine to make a straight line, they add up to 180. They're supplementary. So 2x plus 13x equals 180. Now what? We combine. 2x and 13x make 15x. And then divide by the 15. So x equals 12. X equals 12. Of course, we're not done yet. What do we still need to do? So 2 times x becomes 2 times 12, or 24 degrees. 13x becomes 13 times 12, or... My hand's getting ahead of my brain tonight. 156 degrees. Do those add up to 180?
Yeah.
Yes, they do, so it checks out. Whenever we're working with problems like this, it is nice to just double check it by that they're supposed to add up to 180. Add them and make sure they add up to 180 when you're done. We have other geometric applications that we can run into. One of them is perimeter. Perimeter is the distance around an object. And the perimeter of an object, like a triangle, is just defined to be the sides all added together, a plus b plus c. So for something like this where none of the sides are the same, it's a pretty boring formula. But we have some special shapes that we're going to deal with. One of them is a rectangle. Now in a rectangle, since one of the definitions or one of the rules of a rectangle is that opposite sides have to be the same, if this side is length A, this side over here is also length A. If this side is length B, this one's also length B. So the perimeter is A plus B plus A plus B. But we've learned from our vast experience in algebra now that things that have the same name or the same variable can be combined. So this perimeter, we can combine A and A to get 2A. Plus, we can combine B and B to get 2B. So our perimeter is 2A plus 2B. So if we are told that the perimeter of a rectangle is, what do I put in here? 58. And the length is 17. Find the width. I'm going to modify this formula here just a little bit. Instead of 2A plus 2B, I'm going to do this. The perimeter is 2 times the length plus 2 times the width. Now I'm going to substitute in. Do I know P in this example? Yeah, the perimeter is 58, so I'm going to put 58 in for P. Do I know the length? That's 17, so it's 2 times L becomes 2 times 17. Well, if I knew the width, there'd be nothing to do here, so obviously the width is what I'm looking for. Find the width. So now, just like I did with my profit formulas and my interest formulas, I've put the numbers into the formula. Now it's time to combine what I can combine and then solve the equation. Well, I can combine the 2 times 17 to get 34. And then subtract 34. So I get that 24 equals 2W. And then divide by 2. 12 equals W. So my width that I was looking for, 12 equals 12. That's profound. 12 equals W. So the width that is what I was looking for, it equals 12. So I am done at this point. That has answered my question. No, the width is 12, so that means this is 12 here. This is 12 here. The length was given as 17 already, right here. So let's say we're given a rectangle. We're given these sides are 11. These sides are X. And we're given that the perimeter is 103. Find that missing length. Well, again, perimeter is 2 times the length plus 2 times the width. I'm going to plug in 103 for P, for the perimeter. Do I know L? No, that's what I'm trying to find. It's X. So 2X plus 2W is going to be 2 times 11. And now we're going to go ahead and combine. What can we combine here? 2 times 11 to get 22. Did I really give you a perimeter of 103? Okay. Let me get realistic here. Make it 104. Sorry about that. Very good reason why I did that coming up. So anyway, sorry about that. So anyway, they changed that to 104 instead of 103. Now that we've combined the 2 times 11 to get 22, what would be our next step? Subtract 22. So 82 equals 2 times X. And then divide by 2. So 41 equals X. Now X represents this right here. Is that what we were looking for? Yeah, that's all there is to find in this one. It's just that length. So each of those sides is 41 units. We could say the length of a rectangle is twice the width. If the perimeter is 120, find the length and the width. So again, just like with the angles, I like to sketch it out. This is my length and this is my width. What do I know about those two? Do I have a relationship between them? Well, I have the length is twice the width. So which one am I going to let be the variable? Which one am I going to define to be X? Well, actually, let's look at it this way. the length is twice the width, means the length equals 2 times W, 2 times whatever that width is. So rather than bringing in an extra variable like X or whatever, let's just leave it as the width is W and the length is twice that, or 2W. So my perimeter formula, perimeter equals 2L plus 2W. Do I know P? 120 equals 2L is going to be 2 times, what's L? Well, 2W plus 2W is just, the width is just W right now. Now what can we combine here? Yeah, well, first of all, we've got 2 times 2W, which is going to give us 4W. And now we can go ahead and combine the W's. 4W and 2W make 6W. And then that by 6. W equals 20. And then the width is 20. W is 20, so we're good there. But what else do we need to find? The length is 2 times that. So 2 times 20 is 40 is our length. Have to make sure you go back and answer the question. Since we're dealing with rectangles, we can talk about areas. To understand how an area is created, we look again at that basic geometry, that basic point. We took that point and we moved it in a single direction to make a length. We said the length of that is equal to the distance that point moved. Well, in geometry, we have a concept called perpendicular. Perpendicular means at a right angle, but not just like on a flat piece of paper where a right angle just makes a square corner like that. Perpendicular is in 3 dimensions, which means it's a right angle in every possible direction. You think of a line coming out of the paper. To be perpendicular, you'd have to form a right angle in every direction all the way around the line. So anyway, if I take this length that I created right up here, and I now pull it in a second direction, and there's 2 conditions. One, that second direction has to be perpendicular to the first. And 2, the line has to stay parallel to its original orientation. So if I take this line and I pull it perpendicular, like that. If you think of that as like a stick being pulled across the sand, it'll actually trace out on the sand a rectangle. This has now been pulled in 2 directions, so it now has 2 dimensions. As we saw in the perimeters, we now have not only a length, but we have a width. Along with that second dimension becomes a composite dimension called area. And the size of that area depends on 2 things. First of all, it depends on what that original length of that line was. And second, it depends on what that distance is that it was pulled. So area is defined to be that length times that distance, or in this case, since it's a rectangle, length times width. So pretend that's a rectangle. If this is 7 inches and this is 12 inches, the area will be 7 inches times 12 inches, otherwise known as, well, 7 times 12 is 84. Inches times inches is inches squared. So 84 inches squared, or 84 square inches. Let's say a rectangle is 14 inches long and has an area of 196 square inches. Find the width. So we already know that the length is 14 inches. We're looking for the width here. But we know that area is length times width. So for the area, we put in 196. For L, we put in 14, and we were looking for the width. How do we solve this? Divide by 14. Gives us what? What's that? 14. So the width is also 14. Technically, that would be a square, not a rectangle. But remember, every rectangle or every square is also considered a rectangle because it meets the qualifications. So a rectangle with area of, what do I even put in here? 300 square feet. Has a width of 15 feet. Find the length. I'll let you guys try this one on your own. Okay, so let's draw a picture of our length and our width. What do we know about this? Width is 15 feet. You know, areas, what we're dealing with is length times width. What now? So 300 goes in for A. L times 15. Then what? Divide by 15 gives us 20 equals L. So the length is 20 feet. How many of you had 20 feet? How many have no clue where 20 feet came from? Okay, so at least nobody's totally lost. These are ones that'll take a while to get used to. The more of them you do, the easier they get. You start to see the patterns and feel more comfortable with them. So let's say a rectangle has a length that is 4 times the width. If the perimeter is 280 inches, find the length and the width. I'll give you a couple minutes to do that. So I'm going to draw a picture again. Width and length. Perimeter now, so perimeter equals 2 times the length plus 2 times the width. What do we know? The length is 4 times the width. We do know that 280 is the perimeter. We can put that in. The length is going to be 4W because the length is 4 times the width. So when we plug this in, this will be 2 times L becomes 2 times 4W plus 2W. Then what? Well, 2 times 4W becomes 8W. And we still have the plus 2W. And then 280 equals 8W plus 2W is 10W. And then divide by 10. 28 equals W. All done? No. 28 is our width. The length is 4 times 28, otherwise known as 112 is the length. Good. If we take that area, pretend this is a rectangle, we have an area. And now we take it in a third direction. Now a third direction is going to meet a third dimension. This direction is again perpendicular to the original directions. We create a box. That box has a volume. So this third dimension or three-dimensional object, not only does it have 3 lengths, it has a length, a width, and now a height. It has areas because each surface, each side of this thing has an area. It also now has volumes. And the amount of the volume depends on what the size of this area was times the height that it was lifted or moved. Well, the size of the area is just the length times the width. And it was moved that height. So length, width, and height. Now, how many of you are struggling to draw the boxes like that? All right, I'm going to show you a little trick here. Draw a rectangle. From the corner, just go up and over a certain distance and put a dot there. From the next corner to the same distance, up and over. From each corner to that same distance, up and over, like that. And use that to draw a second rectangle. Connect the corners. You have a box. Yeah, mine get lopsided all the time too. So if this is 20 inches, this is 8 inches, and this is 12 inches. The volume of this box, length of 20 times a width of 8 times a height of 12, is 20 times 8 times 12 is 1,920, I believe. Inches times inches times inches is inches to the third power, inches cubed. A box with a length of 15 inches, a width of 8 inches, has volume of 480 inches cubed. Find the height. So I'm going to draw my picture. Length was 15 inches. Width was 8 inches, and I'm looking for the height. Volume was 480. Length is 15. Width is 8. I'm looking for H. So now here I'm going to combine what I can combine. 15 times 8 is 120. Now what would I do? Divide by 120. Do H by itself. The height, H, equals 4. This is 4 inches tall. So tiles are 1 foot by 1 foot. In other words, you have 1 foot square tiles. How many are required to cover a 9 foot by 13 foot floor? Now draw a picture. 9 feet by 13 feet. The tiles are 1 foot by 1 foot, which means how many tiles is it going to take to go this direction? 9 of them. How many tiles is it going to take to go that direction? 13. 9 times 13 is 117. Better take 117 tiles to cover that floor. Make sense? Let's say we have a 9 foot by 15 foot floor. How many square yards of carpet are used? There's a little problem here. These are feet, and this is square yards. Well, how long is a yard? 3 feet. So if each yard is 3 feet, how many yards are going to go in this direction? 3 of them. 9 divided by 3 would be 3 yards. How many yards are going to go in this direction? 5. 15 divided by 3 makes 5. So it's going to be 3 by 5, or 15 square yards of carpet. Does that make sense? No? The hard part there was the conversion, the fact that each yard was 3 feet. So we had to take our dimensions, 9 feet, we had to divide it by 3 to get that it was going to be 3 yards. Our 15 feet, we had to divide it by 3 to get that was going to be 5 yards. They're just multiplying the 3 by 5. What if I want to know how many square feet of carpet or whatever it's going to take to cover this floor? We only know how to find the area of what? A rectangle or a square, whichever. This isn't a rectangle, but it can be 2 rectangles. I'm just cutting it like that. This rectangle here is 12 by 16. Its area will be 12 feet by 16 feet, or 192 square feet. This one here is 7 by what? What's this dimension? Where'd you get that from? Okay, very good. It's 28 feet all the way across here. All the way across here. These 2 sides must also add up to be 28. If this one's 16, this one has to be 12 so that they add up to the full 28. So this is 7 feet by 12 feet, or 84 square feet. So to get the total area, you're just going to add them up. 192 plus 84 is 276 square feet. Questions? So let me try one. Make that one 30 inches, this one 8 inches, 5 inches, and 15 inches. Find the area of that. So this one I'd probably cut across here. This piece is 8 inches by 5 inches, or 40 square inches, or 40 inches squared. What's this piece up here? Well, what's this dimension here going to be? 20. Because that dimension has to be this one plus this one. So 5 plus 15 gives us 20. What's this one going to be? 22. Very good. Because that dimension plus this one has to add up to the full 30. So 22 plus 8 makes 30. So this piece here, that area, has to be 20 inches by 22 inches, or 440 inches squared. So then we combine 440 inches squared plus 40 inches squared is 480 inches squared. How are you doing? Yeah, so your question to Richmond.
No, I was just going to say. Sorry about that. I slightly did it a different way, but I did get the same answer, so does it matter which variant you do as long as you get the same answer? It does not matter any variant?
No, there's about 3 or 4 different ways I could divide this up. I mean, you could have cut it like this if you wanted to. They'd still add up to the same. Actually, what I sometimes do on these, you see I put the brown line in here. That makes it 20 by 30, or 600 square inches. Then subtract out. This one's 15 by 8, or 120, and I subtract that out. Still gives me 480. So there's a lot of different ways. Was there another question in Richmond there?
I was going to say, do you ever do it the way where you subtract it out?
Yep. And in a problem like this one here, it's about the same amount of work either way. But there will be some problems where it's easier to add them, cut them up and add them. And there will be problems where it's easier to make it bigger and subtract pieces out. But we're not going to get deep into that quite yet. Later in the course, we're going to get more into areas and volumes and stuff like that. Okay, so for now, there is no new quiz for next week, but there is a new homework assignment. So that will be due on Tuesday, or sorry, that'll be due on Tuesday, due on Thursday. I'm all messed up with the day off yesterday. So it'll be due on Thursday. Also, work on your test corrections. If you have any questions on them, I'll try to make some time on Thursday to answer those. I do want to give you a couple of days to look them over and see if you can figure them out on your own first, though. Otherwise, send them to me once you got them figured out, and I'll give you back half your points. So we have about 10 minutes left. At Rice Lake here, we do have the computer lab next door is now serviceable if you want to go over there and work on your homework and get started. Otherwise, we'll see you all on Thursday.